Cast is now starting. All attendees are in listen-only mode.
Hello, everyone. Thank you all for joining today's webinar for Nozomi and Cybercode. We will just start the webinar in about 5 more minutes. Please bear with us, and we will be starting in a bit. Thank you. Good afternoon, everyone. Thank you for joining our webinar. My name is Nadine Shamas. I am account manager at Exclusive Networks, handling Nozomi Networks. I will just go give a brief about Exclusive Networks and who we are. Then I will be handling to our partner, Mr. Farouk Al-Jibbouri, and then our Nozomi team, Bashir, Khalid, and Michael will also be from Nozomi team. They will be presenting as well the beautiful solution that we are hosting for today. So at a glance, Exclusive Networks, we are a global distributor. We handle around 26 vendors in the Middle East region. However, globally, we have around 70 plus vendors that we work with. We were founded in 2003. Our headquarters are in Paris. We are a $2.5 billion revenue company. Our revenues double every 2 years. We have around 1,800 employees worldwide. And as for the vendors that we work with cybersecurity vendors and cloud transformation vendors. So when I speak about cybersecurity and IoT vendors, we are talking about Fortinet, F5, and Blocks, all the way to Nozomi. And then when I speak about cloud transformation vendors, I am talking about Nutanix, Rubrik, Cloudian, and all the way to Haiku, which is the backup storage. So this is it at a glance. I will leave my contact details in the chat box. So please reach out to me, to Farouk, to Nozomi team, whenever you have any questions. We will be answering some of the questions in the middle of the session and some in the end. So this is from my side. Farouk, please, if you can go ahead.
Yes, okay.
Is that common devices that may not have been so intelligent in the past are now connected is apparent just about everywhere. Train stations now, the video board that tells you what train you're supposed to be connected to. The trains themselves have 10 or 15 devices that are connected to the internet. Airports, we mentioned hotels and buildings. You have building automation systems, fire suppression systems, safety systems. These are all, examples of the continuing evolution to get everything connected to the internet. We're also seeing a convergence of the types of technologies and the teams and the processes that are in place for these unique IoT types of networks and OT networks, so operational technology networks that Nozomi Networks got started in, distributed control systems, SCADA systems, and your standard IT systems, to the point that you're going to see, a lot of the same operating systems, a lot of the same people that are responsible for monitoring IT are getting responsibility for monitoring these OT networks, this Internet of Everything network, and they all present unique challenges, and there's unique protocols and unique devices. So what Nozomi Networks mentality is that we have a specialty, a unique capability to monitor and discover threats in these unique networks. Our background, as mentioned, is in operational technology. We've deployed our technology for years at oil refineries and power generation facilities and electric transmission and distribution, and now we're seeing more airports and hotel chains. So that's the background that we have. And these IoT, this Internet of Everything, is an evolution of that. There's still unique protocols. There's still unique devices with their own unique threats. And the ability to be able to understand what we're seeing on those protocols, understand what those devices are trying to do and how they communicate, it isn't really that much different. It's just a matter of building support for those protocols and building support for those devices. So that's really the thought process behind our product innovation. If we can monitor those operational technology networks and all of the really interesting things that are happening there, we can do the same for the IoT and the Internet of Things, and give end users a single window of visibility into all of the communication flows and devices across those networks, and the ability to manage threats and manage risk for those unique environments with a single solution that can roll into your IT cybersecurity program and your overall cybersecurity response capabilities. Some of the innovation that we've brought to the market with that focus, starts back at our very first implementation. The product was developed by two Italian PhDs, one a PhD in artificial intelligence, one a PhD in monitoring, process control protocols. He wrote his thesis on monitoring process control protocols. They first brought this product, out to look for investors and look for initial customers in, the early part of the decade, 2013, 2014. And we're able to actually get it implemented right out of the gate at a national power grid, one of the major utilities in Italy. And we actually were able to develop the solution and develop the monitoring capability, in the real world, actually monitoring a very, important part of the European electric grid. So the success right out the gates of having a solution that was fully artificial intelligence powered, a full stack solution, which means we own all of the code, we own the operating system, and to work out the kinks at a major utility gave us a major advantage as we started to bring this capability to the market, which we eventually did in June of 2016. So we launched the product in the market in 2016, mostly in Europe and the Middle East. Actually, many of our biggest initial clients were in the Middle East. We're in Dubai. We're in Saudi Arabia. So we really started to get a focus on the market from Europe and the Middle East from those early days. We were the first application to combine network visualization, asset inventory, vulnerability assessment, and threat detection into a single interface, and introduced a hybrid threat detection component in 2017, actually using threat detection techniques beyond just signature-based detections, but also correlating those with anomaly detection and indicator-based detections using tools like Yara at an early stage. 2018, we brought active asset inventory capability. So the core foundational capability of the product is passive. So this means that we're just at this point monitoring the network traffic to be able to uncover assets and be able to make threat detections. In 2018, we brought an active component to do active asset identification using, in some cases, the native protocols of the devices that we needed to build out that asset inventory for. We introduced a threat intelligence service in 2018, a container-based delivery model in 2019, which means you can now get Nozomi networks deployed embedded within your switches and your routers, or in some cases, your other security tools. And brought a behavior analysis capability to the market in 2020. The behavior analysis is focused on, let's not just be reactive to what we see and what we expect to see based on what we've already seen. So learning the environment and making detections based on anomalies or rules, but let's actually fully understand how those assets are supposed to behave. Take a PLC in a control system, for example. We know who the vendor of that PLC is, what types of devices it's supposed to communicate with, which protocols it uses, even what function codes are supposed to be used with that PLC, depending on who the vendor is, and even variable ranges, things like that, and make detections based on just known operation. So we know that PLC is managed via SSH and it's not supposed to see a telnet connection. We're going to make an alert based on that. So we combine all of this different innovation into a solution that allows for quick visualization of a network, quick ability to understand if devices are operating ways they're not supposed to, and we then use an artificial intelligence capability to baseline the network and start to detect things that are, maybe not signature ready, but are anomalous based on, past indicators or past behavior of the environment. So a very detailed, thorough, and hybrid approach to a number of key functionalities that you can typically already find in IT environments, but we brought this in a combined solution that's easy to implement, easy to manage for those unique networks, for operational technology, for IoT, for the types of verticals that I talked about earlier. So what are some of the use cases that we're attempting to cover with a solution like this? So I'm going to talk to really two foundational use cases right off the gate here. So we'll start with operational visibility. What do we mean by operational visibility? This goes beyond just having a high-level understanding of what devices are out there and how they're communicating. What we mean here is a very deep look into the inner workings of an operational network or an IoT network. What assets exist? What devices are out there, and what are they? Who are the vendors? What types of devices are they? Okay, so it's a PLC. Do we know the product name? Do we know the vendor? Do we know the firmware version, serial number of each of those PLCs that are out there? And be able to do this with as minimal risk to these unique environments as possible. In operational technology, it's not possible to go out there with a network scanner and just start scanning the network with all kinds of noise, because you could potentially impact the operation of what that facility is actually supposed to be doing. So if that facility is supposed to be generating power for a metro area, and you go in with a network scanner and take a key computer down, all of a sudden you might see people without power. There's too much risk in that. So passively, just by monitoring network traffic, can we get an understanding of what assets are present on the network, how they're communicating, who they're communicating with, and then just fill in the gaps with an active approach as required. So you get this complete visibility, even a visualization of everything as it's communicating, an automated and accurate asset inventory, and you want to take a bit of a deeper look where you can. Go beyond just seeing the assets and protocols, but let's look at the throughput and details of the communications, regardless of protocol. In the industrial side, can we see the function codes and even the variable information, and start to actually do monitoring for activity that is outside what you expect to see based on the things that you've seen already. So if we see in the process variable information, how fast the turbine is supposed to be spinning. So going back to power generation, typically there's a turbine control system, there's a turbine, it's spinning at certain speeds in order to generate electricity. We can actually learn that based on the information we see. And if it starts to go too slow or go too fast, we'll be able to make an alert that says, we see that the speed of this turbine has changed outside of the range that we expect it to be operating in, and we're going to correlate that with other threats that we might see. So, so we saw that there was an engineering workstation that may have been compromised. We saw, some rogue SMB traffic. We saw some malware pass to it, and once we saw that malware pass and that device get compromised, that's when we started to see a change in the speed of this turbine. And those things connected might mean that, not only was this device compromised, but whoever did the compromising may have been able to start impacting the process. So one key use case here is that operational visibility side. So that brings us to our next use case is, now that we have visibility into the network, so we see the devices, we see all the communication flows, we know the protocols and the anomaly or in the process details. How can we detect threats and do anomaly detection based on that data? You want to make sure you're looking for a hybrid detection capability. So just putting out an intrusion detection system with just rules is very insufficient. Rules are only typically written for, well, first of all, they're written primarily for IT. There's not a lot of OT specific rules out there for intrusion detection. I apologize for the train in the background. I live right next door to a train station. Some of the fun of working from home during a pandemic. But also, rules are only going to see things that have been written about, have already been detected, and that you've updated the rule sensor to look for. And many threats that you're going to be looking for, don't have known behaviors that you can look for with a rules engine. So rules engines are powerful. They can look for, it's a great way to look for malware. It's a great way to look for known threat actors, but it can't be the end all be all. So using indicator-based detection. So we know if we see certain tools in use in the network, especially if we haven't seen them before, and we see those tools doing things like, looking at the network for specific port openings or specific protocols in use, that could be indicative of specific threat actors. So look for indicators, threat indicators, compromise indicators. And anomaly detection helps uncover the 0 days. So, learn the network and look for things that are anomalous to past behaviors, and combine that with your signature detections and your indicator detections. You want to make sure that you can get powerful correlation so that you can actually allow your security teams to easily maneuver through the alerts and piece together, what actually might be not just an incident, but potentially a targeted campaign, by a nation state level threat actor against your organization. Just depending on alerts as they show up to a SEM, and responding to each, incident or alert in a whack-a-mole fashion is not going to allow you to uncover advanced threats. You need to see not just some tool-based correlation, but then once you have that tool-based correlation, do your security teams have the capabilities and information available to them to start piecing together the puzzle of what's going on in the network. And that requires detailed alert information. So detailed information in all of your security tools, in how they alert what they see on the network, and provide the tools and functionality to dig deeper. Packet captures related to incidents, detailed, variable logs for when there's an anomaly in the process. All of this is important for responding to the event and doing forensics. And then, of course, integration capability. You want to make sure that in your monitoring solution, you can get everything back into one place, so your security team has a central point of truth. And that may not always be, the solution like ours that's out on the industrial side. It's typically going to be a SIEM or a SOAR system, or excuse me, something like Splunk, where you want to make sure you can aggregate all of the data and respond in a central place. So built-in support for SEMs and an open API, those things are crucial in a monitoring tool. Just a quick look at some of the challenges that we typically see during planning and deployment of a solution like this. So once again, going back to describing what the Nozomi network solution does is where we're starting with passive monitoring of your industrial or IoT networks. Passive monitoring means that we need to see mirrored traffic from the network. So that could be setting up a span or mirroring port on a switch or router. It could be utilizing network taps. It could be utilizing network aggregation or sidebar networks in order to see that traffic. But whatever that is, there's common issues during the planning and deployment of this, including making sure the traffic mirroring is configured correctly, understanding who is responsible for setting up the traffic mirroring. In many cases, we've gone on to deployments and we've seen that the plant operators don't have that responsibility or capability, so they look to the vendor. The vendor says that it's on the plant operator, and you find out that no one actually owns it. So understanding who owns management of the switches and routers and is capable of setting up traffic mirroring. How will it be set up? How will the approval process get done? Can it safely be done in the production environment? Traffic mirroring does have its own resource utilization, and the switches and routers, especially in industrial environments, may not be scoped to capably handle all of the extra load that will come with mirroring traffic to an additional port, and that may mean that using something else like a tap or an aggregation tool is going to be required. And do you know where all of the switches and routers are in order to do proper monitoring? Is there anything hidden out there that you need to make sure you uncover and focus on? So there's common issues with setting up the traffic mirroring. Okay, so the next step is you've got those issues resolved, and you've got your span port set up, and you know that you want to do traffic mirroring now. Are we properly scoping the hardware for monitoring it? So traffic throughputs are typically estimates, doing some type of verification to make sure that you have the right data for properly scoping the device. If you're using embedded or containerized versions of another tool, so as for an example, if you want to run your monitoring software in a Cisco Catalyst switch, understand if the resources that are standard are going to be sufficient to also run monitoring solutions. In many cases, it's not, and you're going to need to install additional memory or additional modules to be able to do that. Do you need ruggedized? That's one of the unique characteristics of attempting to do monitoring in industrial or IoT is oftentimes you don't have a nice air-conditioned, cooled cabinet to put these appliances that are doing this monitoring. Do you need something that can withstand the heat that can often be seen in desert environments or dusty environments that you might see at substations or just other outdoor environments that you don't have that ability to maintain and control a clean environment required for standard IT tools. So do you need ruggedized equipment that you can put in these environments is a major point of emphasis for success here. And then making sure you're planning for all of the integrations and who's going to be monitoring. Setting up a solution like this has a requirement that eventually someone's going to be responding to and doing something with the data. So have you gone through the process to make sure that you understand who's going to be responsible for managing the implementation, responding to the events as they happen? What is going to be that single point of truth for this data? Is there going to be a SIEM or a SOAR system? Do you have a managed security service provider that can handle these responses? Where do you want to locate it? Is there a DMZ set up? And then making sure that all of these stakeholders are properly trained in using a solution like this and properly trained in how to respond. So it's just some basics in planning for and getting set up for a monitoring tool. What I want to go through now is just some of the common things that we discover in these types of implementations. So I'm going to do this part pretty quick. So common findings. So here's some of the things that we see when we get a chance to run proof of concepts and to run implementations of this product in production environments. We see devices connected to the internet that probably shouldn't be, especially when you're dealing with industrial control. Connections to the internet are often very, very dangerous because the systems on your network can't be regularly patched, or they're running old operating systems. And there's an assumption that these networks are air-gapped or in some other way protected from direct internet connections. But when we get in and start doing implementations, we often find that that's not the case. One internet connection could potentially lead to malware or viruses that in an IT environment have been patched for 10 years that can propagate to an OT network and wreak havoc because those patches just can't be implemented. So important to understand at least where your internet connections are, see if they can be eliminated, and if they can't be eliminated, make sure that they're properly managed to avoid those potential issues with bad traffic being able to reach your network.
Yes, Michael. I mean,
Another
sorry to
example of
interrupt.
that.
This is something we regularly see and hear, specifically in Iraq. So they're gonna tell you this is an isolated network or air-gapped, and it's potentially not touchable. So what is usually the argument we should pay attention to?
I think something that's very important to understand is that the concept of an air gap in reality is a myth. It is very, very unlikely that a network is ever truly air gapped. You have vendors and partners and workers that might go out to work on these systems and connect their laptops back up through a cell link, or your vendors might have wireless access points set up so that they can reach in and do monitoring, or just cabling errors in the way that the networks are designed. I think there was a study done this is a while ago, even maybe 7 to 10 years ago, about air gaps. I don't remember if it was Industrial Defender or Waterfall or someone like that, but it found out that in supposed air gapped environments, 90% had some type of connection back out to the internet. And that's typically the reality we see when we plug these devices in, is that and the air gap tends to be a mythical way to feel safe, but in most cases it's not even reality. And even if you think that you have that air gap and you go through and you check and there's no cables and there's no internet connections, there are data collection techniques now that use things like heat or use sound to do data collection from these networks. So even if you do manage to keep a proper functional air gap in a networking sense, that there's no network connections, there's no wireless access points, there's nobody dropping USB sticks in, which is another good way to beat an air gap. There's advancements in the way that threat actors are able to collect data that none of that's even required. So skipping monitoring because you think you have an air gap is a sure way to miss potential activity on your network that could be malicious. Becomes more of a foolish approach on a regular basis. There's really no such thing. As we saw in the attacks earlier in the decade in Iran, in the Stuxnet attacks, there was the thought process that those facilities had an air gap, and it was beaten by a USB stick. That's typically all it takes. One person plugs a USB stick into one device that didn't have those devices that didn't have those devices disabled, and all of a sudden all of those precautions to keep the network off of the internet are beaten because that USB stick that was connected to a device that was on the internet somehow got infected with all kinds of malicious code and malware and gets plugged in, and that just transfers from the internet to your air gap network via that one little device. I know there's approaches now to say that let's disable every USB port. One, it's impractical. It's one of the only ways for transferring data into an air gap network. And even if you did want to take that approach to believe that you're going to find and functionally disable all of them, it's a very difficult errand, and there's typically a lot of other things that people are focused on. So just something to think of. There's typically never a real air gap. Okay, moving on. Other findings that we see. We often find a wide variety of OSs and firmware versions in the networks, often typically beyond what you believed you had out there. You may think that you're getting everything updated, that you don't have any operating systems out there that are unsupported. Very common that we get out there and we see significantly more than was understood to exist. And that may be because, whoever was responsible for the updates just missed some devices, or didn't know that the devices were out there. They weren't on the initial checklist. It could just be that, it's impossible to update some of these systems. It's very common, especially once again, going back to operational control networks, that you're going to see Windows NT or Windows XP or, other unsupported Windows operating systems that have a significant level of risk because of the inability to get them patched. And the same thought process goes for, PLCs and other embedded operating systems. Those have firmware. Those tend to be patched to resolve vulnerabilities in, at least at the recommendation of the vendor, but the actual ability to patch these in the networks is not always, not always possible. And this brings us to identifying and understanding software and firmware vulnerabilities. So a very common finding for us is, even sometimes within a few hours of plugging in, we start to find all kinds of software and firmware vulnerabilities. It's a very simple process for us. We build the asset inventory, and then once we have the asset inventory, which is completely automatic, we start to cross-reference what we find out about the assets against the vulnerability database. And as we cross-reference against that vulnerability database, we uncover, where we see, here we have some vulnerabilities with, OpenSSH. We see vulnerabilities with Chrome. If I move to the next slide here, we see vulnerabilities with the PLCs themselves. So this is a Rockwell 1756 PLC, and I can see that there's a lot of, especially improper authentication and information exposure vulnerabilities with the firmware of that PLC. Once again, the vendor probably released an update to resolve those vulnerabilities, but it is not practical in many times for you, the operator, to go out and then patch and update the firmware of a PLC every time one of these vulnerabilities needs to be resolved. So understanding what's out there and understanding how these vulnerabilities can be taken advantage of so that you can do other types of mitigations instead of a firmware update when required is very useful. Unknown or misconfigured devices. So these are examples of, we see function code scanning, or we see attempts to use function codes that aren't supposed to be used for those devices. This is often a simple misconfiguration, but it can also be indicative of somebody that has presence on your network from outside, just trying to find out how things operate and how they can get access to the industrial devices and potentially change things. In many cases, once they reach a network and see a device that they recognize, they may not understand how that device is configured and what it's going to respond to, and they scan to look for ways to get access. Function code scans and improper function codes is a pretty common detection capability for unauthorized access and unauthorized attempt to use those industrial devices. Real basic stuff sometimes. Maybe it's not known threats, but maybe it's just serious networking issues. We see high levels of TCP retransmissions. That could be something as basic as a bad cable. One of my favorite proof of concepts that I did at a major oil refinery, they were having serious operational issues and had exhausted all resources to try to find out why, and brought us in expecting to potentially find some major cybersecurity event. And we came in, and within a few hours, we uncovered that there was a couple of very important links that were seeing 50 to 75% retransmissions. We go to check the cables of those links, and sure enough, it was not a controlled environment. The more ruggedized cable was needed, and they just deteriorated, and they were not performing, as they had been performing when they were deployed 10 or 15 years ago. And replacing the cables solved operational issues that were causing hundreds of thousands of dollars of lost production daily. So, something that very simple and basic is very important to uncover in many cases. It has nothing to do with security, but is often, if you're not looking for it, very difficult to find. There's probably not someone going out and checking the functionality of every cable in the network on a regular basis, but this is a very basic thing that can cause operational deficiencies. So here's another example, just another visual example of availability monitoring. In many cases, this is an operational link. This is Oracle. This is an Oracle connection. Should have 99.9% uptime. So we're just seeing this one we checked and had less than 95% availability. That 5% gap, could be potentially serious. Could be more serious if it's more of a production related environment. Unencrypted or weak credentials. One of the things that we're looking for, looking for clear text passwords, looking for people that are using default credentials on devices. This is one of the easiest mechanisms for an attacker to move his way around the network. The hard part is often getting in the first time, and that can be accomplished by ways that are really difficult to manage. Phishing or, malware brought in some way, shape, or form, that connects back to a control center. But once an attacker's into your network, the important thing is, how do they get around? And jumping from router to router because the routers have default credentials is an easy one. Or sniffing the network and looking for credentials to machines that are left unencrypted so we can use them to jump around the network is another common technique. So that's one of the things that we're looking for is, the unencrypted clear text type of credentials and weak credentials and default credentials being used on the network. Abnormal device operations. So this goes back to monitoring. On the process side, but we can see that this is an analog for Siemens S7. So this is monitoring Siemens S7, and it looks like it's supposed to be a simple on-off. And you can see that there's a big difference between the first 8 hours and the second 8 hours being looked at here, and that there was almost no variance in whether this was this is going from 0 to a max value of 81. And then it changed drastically on the second end, and we see a lot of variance there in that S7 link. So this is just something worth monitoring on the process side This could be indicative of any number of things, but this is just the monitoring of a Siemens S7 link, looking for looking for those variances in operation. And then something that's not unheard of, not common, but not unheard of, we go in and we plug in the box, and after about 10 or 15 minutes, we realize that environment that we plugged into is already completely compromised and infected, and there's all kinds of things crossing. We've gone into deployments and seen things like Configure malware just spreading like wildfire across the network, or everything's already infected. We've seen ransomware. We've seen instances where there's obvious activity from someone other than the customer, jumping around the network, just by plugging in. Sometimes, you hope that you're not going to see this, but sometimes it's good to plug in a solution like this, and in 20 or 30 minutes, all of a sudden you see, everything start to go red, and right away that there's going to be some action that needs to be taken. So once again, not common, but common enough that maybe in the 2,500 or so deployments that we've done, we've seen this 5 or 10 times where the network's been completely infected before we got there. So what I want to do now is can do a quick demonstration of the product, but one of the things that we did to potentially make this more effective is to give everybody on the call the chance to kind of watch it live and play around with the systems themselves. So let me pause the sharing for just a minute. How do I do that again? I haven't used GoToMeeting in a little while. Sharing, I'm going to pause that. And in the chat window right now, I'm going to drop in a bunch of IP addresses. So for anybody that's on the call, if you want to actually open up a Nozomi Networks interface, you can just browse to any of those IP addresses. It doesn't matter who uses which one. Multiple people can be on the same one. That's okay. I just wanted to have a lot of different examples, but we're going to make this kind of a live demonstration. So if any of the attendees that want to log into one of these and look, I'm going to guide you on where to go, but you'll be able to kind of click around yourself. Let me put the credentials in there too. I guess that's important. So just don't use the top one. I should have left that one off there. The top one's the one that I'm going to run the demonstration off of. So that 54.246.242.33 in the chat, just stay off of that one. I'll use that one for the demonstration. The rest of those, you're welcome to log into. And here is the credentials. So just a minute. Let me open up my system and make sure that I have my terminal window running so that I can actually run the scenario. All right, good. Have everything. Let me share my screen again. All right. So if you're following along, this one's being rebooted. So let me log into a different one. The only problem sometimes with using these interfaces in the cloud. So these are all set up in Amazon Web Services. So sometimes they reboot on us, and it takes a while for the reboot to happen because we don't give them much resources because it costs a lot of extra money. Here we go. All right, I'm logged into this one. So if you're following along, if you're logged into any of those IPs, and if the one you try to log into has the same error as mine, just pick a different IP address and try to log into it. But if you're following along on your own, what you want to do for the start of the demonstration is go to Environment, Network View. So the Environment tab, Network View, and then go to the Graph. So there's a tab there on the far right over here that says Graph. And this is where the visualization happens. So what we have right now, these are all blank systems. They're all blank systems connected to the internet though. I'm going to set this to from the beginning so that we see it all the time, but then there's another button there that says live. And I'm going to turn that on to live. And then what I'm going to do is I'm going to run a packet capture from elsewhere on the cloud to all of these machines to start to fill out the graph. So this packet capture will will look like an industrial environment, and it'll start to map out what that graph is supposed to look like. So give me just a minute to go back to my terminal here. We're going to play the base script. So where's that at? Inject. Oh, no. Yeah, there we go. Inject base PCAP. Oh, I guess I gotta. Why is that not working? All right, just a minute.
You need to upgrade your Windows machine.
I have some instructions on getting it. It just worked for me a few times this week, but now I have a brand new laptop today, so I should have assumed that because I'm running a brand new laptop that everything would kind of go wrong. So I'm missing something. Let me check it real fast. Is anybody else on the call watching this live? So did anybody get a chance to log into one of the other systems?
Yeah, I'm
just
all
interested if we're gonna use. All right, cool. All right.
Wouldn't it be easier to just use the GUI to just inject the PCAP without the?
We can, so everybody can. So the PCAPs are preloaded into the GUI. So worst case, I can do that. But if I use the script on my laptop here, it's actually going to send it to everybody. So everybody that's logged in will get the traffic at the same time, which is really cool. So give me 2 minutes to see if I can resolve this, and if not, we'll just use it in the GUI.
Cool. Yeah, so it's, as Michael said, usually you can just use the web interface to inject any PCAPs or traffic captures. But what he's trying to do now is basically send the traffic capture, or the PCAP, to all the devices that are being used. That's why he's using the terminal.
We'll give it one. Yeah, give me just another minute. If we don't get it running, we can just do it with the PCAPs that are already embedded, which is a worst case. Why? Oh, you know what? I think I figured it out. Just give me 2 seconds. I didn't run the initial setup, I think. No, I think I know what it is. I didn't install TCP replay on this laptop yet, so it's not going to work. So yeah, let's use the graphical interface. Darn, new laptop. All right, so once again, anybody that's following along, we're going to do this the easy way. So go back to the administration tab and the upload PCAPs. The PCAPs that we're going to use are already loaded. So this is another way to do it. So if you just hit play on the base PCAP, and then go back to your graph view, so environment, network view, graph, you'll see that base PCAP playing on your screen there. So the reason I like to do this interactive versus just doing a demo, so everybody can kind of have hands-on, is you can kind of click on anything you want by this being more of an interactive demo. But I'm going to guide you to some of the things that might have some interesting data. So what we have here is a visualization of that base packet capture, which includes a couple of Modbus networks, a couple of IEC 104 networks, which is somewhat common in the electric substation space. We have some Ethernet IP, which is a common Rockwell protocol. Couple of historians, some HMIs. So this is just a visualization, and we did the learning, via that first few seconds of running the packet capture. We did the identification of the role. So if I click on the legend here, I can see that there's There's a historian kind of in a pink color, the consumer or the kind of the master workstations in the red, the PLCs or the producers in blue, and the terminal stations in green. So the HMIs are in green. So we color coded it there. And this is interactive. So if I want to click on one of those links, first I'm going to open up the info button on the right. So on the far right, you'll see a tab that says info. You can open that up. It'll be blank when you start. But if you click on one of those network links, I'm going to click on one of these IEC 104 links, you'll see all of the data about that network communication. So in this case, I can see the from and to zone. I can see the amount of transferred data, retransmission rate, whether it's been learned or not yet. A lot of good information there about that network. In the red, I can also see the function code. So I can see this is an IEC 104 link. I can see function code 1, 9, 15, 104. So a lot of good information about the function codes that are in use. You can also click on the assets. The IEC 104 PLCs won't show quite so much because the IEC 104 protocol doesn't include a lot of traffic, a lot of asset detail in the traffic. But if we go to the Modbus or Ethernet IP networks, so let me click on, I'm going to actually double click on one of these PLCs. So I just double click on one of the PLCs on that Ethernet IP network, and this opens up the asset detail information that we have for this. So in this case, this is a Control Logix 1756 PLC, so Rockwell Allen Bradley. We can see that I've got the firmware version, the serial number, and then identified it as a PLC. So this is just through passive monitoring. We passively identified that that this is the device information. Because we have the firmware version, and we also have the hardware component information. So if you look at the bottom right, you can see that I've got the serial number and the firmware version, some of the different components of the PLC, the redundancy module, the communications adapters, all of that's been identified. If we go to the vulnerabilities tab, we can see the vulnerabilities that have been identified for this device. And if you're connected to the internet there, you can also then click on the CVE link and get details about that vulnerability. So that this page will load just within the GUI, but from here you can get, I can see the vendor advisory. I could see details about the drivers, or in some cases you'll see advisories outside of the vendor, from the researcher. We'll put links in there about that vulnerability where we can. Bunch of vendor advisories here for this one. And you can see the CVE source, Nozomi curated. That means we've actually gone in as part of our threat intelligence service and manually modified the CPE matching data to make sure that it's accurate. So we've eliminated false positives and false negatives by that approach. No variables for this device. So let's go back and I'm going to open up one of these Modbus ones instead. So this is a Modbus. Here we have a Schneider Electric Modicon PLC version 2.9. So you should see something like this if you're following along with us on one of your own devices there, your own virtual machines. You'll if you open up any of the PLCs that are communicating via Modbus, you'll see this. In this case, we have vulnerabilities as well, 4 high vulnerabilities, 43 medium vulnerabilities, and we have variable information. So in this case, we've actually seen there's a bunch of read registers. I see one with 188 changes, and if I open that up, I can actually see the history of the variables. So I can see the history of the values as they cross the network. So in this case, is the minimum value, maximum value has kind of been identified. So we have some interesting data there. You can get more of this if you go to the just environment process view. You can get a lot more detail about all of the variables. I like to sort this by changes sometimes. And if you click on the magnifying glass of any of these, you can kind of look at the variable values for any of these Modbus links as they came across. Going back to the network view. So we were on the graph. Now we can also look at the nodes. This is a list of nodes. I'm going to, on this 9 selected, I'm going to add a bit more detail for each of them. So I can do some search. So in this case, if I want to look specifically for all of my Rockwell devices, or I want to look for everything that's got a Windows operating system, I can go over to operating system and I can start typing in Windows. And here I can see a bunch of Windows XP, a bunch of Windows 7. And if you open those up, you'll get the details of these devices as well and what we've identified for it. So we see it's a web server and a consumer. We see some alerts, new confirmed protocols, new links, and then we can see the vulnerabilities. In this case, it's a Windows system, Windows XP. A lot of these can't be patched, or they might be application vulnerabilities. With Windows, you might want to get more detail using WinRM or WMI, one of the active protocols, using our smart pooling capability. We don't have that set up on here, but if you want to check and see how that works, you can. I could say for my Windows XP devices, I want to use WMI to run some commands at the Windows system to get the patch information. So you have the ability to do that with the smart pooling. Let's look at the alerts. So it looks like on mine, I don't know if it's going to be the same for everybody's, but on mine, the learning wasn't really set up to happen. So there's a lot of alerts right out of the gate here, 257, 18 pages of them. See some internet navigation. I actually can go into, I'm going to go into expert modes. On the top right, you can switch from the normal mode to the expert mode. And I don't want to group it by incident. I want to ungroup it by incident here. And you can actually look at the different type IDs. So I can see, new SCADA node alerts. If I clear that, I can see new function codes, protocols. So there's not a lot of real interesting alerts yet. So what I want to do now is let's go back to administration, upload PCAPs, and let's run the attack PCAP. So we're going to run the one on top, attack upload.pcap. Let's give that a few minutes to do its thing. So I'm going to go back and look at the network again. It looks like there's some more stuff that's starting to pop up on the network now. All right, so we're seeing voice over IP phones have been uncovered. There's also some camera systems that have been uncovered now. So we're starting to get a lot more data about the network as the PCAPs keep playing. I'll just check my learning. Okay, so yeah, I see what happened is I took too long to play the PCAP, so the learning actually finished before I played the first PCAP, which is all good. Let's go to alerts now, and now we're up over 1,000 alerts. So we got 77 pages. I'm going to do the same thing. I'm going to go into. All right, so we've got some malware detected. So I'm going to use that signature malware detected, and let's open up that. So what's nice about the alerts in Guardian is it's actually going to give you a graphical view, a graphical representation of where the alert was detected at. So in this case, we see suspicious transfer of malware named Dragonfly, detected involving resource control engineer.docx. So there was a Word document that had malware embedded into it that was passing the network, and we detected Dragonfly in it. And that looks like a communication between, it's kind of an unrecognized new device here via SMB back to one of our master stations. We look at related alerts. We started to see some new links, new function codes. The baseline didn't finish, so there's some other stuff that could be there that's not on the anomaly side, but just an interesting malware detection there. And let me see this producer, 172.16.0.55. Go back into these related alerts. Wrong button. Back into these related alerts. Oh, starting to fill in with more. New confirmed protocol, new node, new link, packet role matches, malware detection. So a lot of alerts related to that one. Cool. Let me clear that out. Anybody following along, seeing kind of similar things, running into any issues? Not all right. So you can look at other alert types. So we've got some packet rule detections. There's a man in the middle alert there. So if you want to keep looking at the alerts, you can do that. We can also go into the analysis and look at how we can look at some of the kind of the data, the underlying metadata of the system. So there's a very powerful querying tool that's built in. So if I want to look for, show me all function codes, specifically interested in where the protocol is Ethernet IP, and sort by most frequently used. So I can quickly kind of query through and get a list of, this is all of the Ethernet IP function codes in the network. What are the most frequent? What are the least frequent? There's a tool to help with the querying functionality that's available as well. You can also turn these to rules. But let me go to the tool. So there's if you click over on the far right, instead of using the typing, if you click on this button here to go to the build a query mode, you can kind of start from a number of different things. I can say I want to see assets, where, and then you can kind of put in the say the firmware version is a certain thing, or protocol equals Modbus. Actually, no, because that's not going to work. Or let's say role equals producer. See if that'll work. Maybe I don't need the assets there. Let's do nodes. All right, so there's nodes. And let's look for all of our Cisco. So I'm just going to copy the Mac vendor Cisco. Nodes where Mac vendor equals, you can use includes, it should work the same way, Cisco systems. And now where we have every device where the node is a Cisco device. So that's kind of how the query builder works, kind of help to work all the different systems. There's a lot of different data that you can get out of that. So I can see, all my links. Oh, missed a letter. You can pick a protocol. So here's all my Ethernet IP links. One of the other things I like to do sometimes is actually build a graph, and you can build a graph with the queries. So let me go back to default. And there's actually an example one at the bottom here. So if you go back to analysis queries, there's some example queries. And if you start with the draw a network graph with your HTTP links, this will draw us a graph in the query builder of all of our HTTP links. And you can just modify this to say, I want to see, do we have any VNC? So there's all your, potential remote desktop, remote access type of links. There's all the VNC links on the network. Or we know that the malware that we detected was via SMB. So run a query showing a graph of all the SMB links. So here's all the SMB traffic. And this is how you can kind of start to do your own threat hunting or mapping out of your network of things that may or may not supposed to be happening. I don't know if we have it saved to, let me see, captured. Take a look at captured URLs. I don't know if I have any. Oh, there we go. So there's captured URLs. Protocol equals SMB. All right, so I just ran a query for all the captured URLs where the protocol is that SMB protocol. And in this case, we could see everywhere that potentially malicious document had crossed the network. You can also do a captured files and see what files that Nozomi has detected and put into the sandbox for investigation and whether it's malicious or not. So we got there's a couple directory files, a couple Word documents. We can see that control engineering doc1 was not malicious and did not get quarantined, but this control engineering doc2 we found out was malicious, so we went and dropped it into quarantine. So one of the things, since we kind of focused on watching the graph build out, watching the asset list build, looking at alerts, looking at queries, we didn't do some of the basic stuff, just looking at the main dashboard. So just here's an overview of the environment based on what we've sent in so far. So we've uncovered 232 assets. 265 nodes, 257 links, and you can click into any of those to look at that detail. We see 18 protocols, 500 sessions, and 1,600 variables. So if you put this in your environment in a proof of concept or in production, very quick. We've only been looking at packet captures now for about 20 minutes, 25 minutes. Get a pretty good, indicator of what's been going on the network. And you can see the, traffic by type of traffic and alert flow by type of alert. Off on the right there as well. And you get a pretty good idea of the situational awareness of your network from the first few minutes as well. So I can see that there's 253 unidentified assets, 2 attempts to link to the internet, and I can click into that and look at them. 106 open vulnerabilities. We got a multi-homed asset, 6 assets that are governing the overall process, 12 clients with SMB shares. This is all interesting things that you can investigate. I'm going to go and look at that didn't show up. See there we go. Here's the 12 devices that have SMB shares. And you can also do this right on the graph. So if I go back to environment, network view, go back to the graph, this has kind of got a little bit of everything, but you can filter it here. So I want to filter this and have it show me only my SMB, VNC, and SSH links. And that'll filter down the graph into kind of only the thing that you're looking for. So, as you start to play around with this, you can get an idea of, the level of visibility that you can get very quickly by putting a tool like this in, and how you can kind of sort your way around to uncover, potentially communication links that aren't supposed to be there, potentially malicious activity. Let me go back to kind of showing everything, as well as a pretty detailed view of what's going on with your process and who's communicating on the network and how you want to use it and learn it. All right, so since we got say 20 or 25 minutes left, and since the baselining didn't work the first time, I'm going to try it one more time now that we know that this didn't work. So if you want to clear the data out and restart the baselining process, so we have the baseline right now, just to understand what we're doing here for demo purposes. We have the baseline set up to learn the network in just 120 seconds. So in this case, because I was playing around with with trying to get the packet dump to work via TCP dump and didn't, we missed that baseline window, so nothing ended up getting baseline. We see everything in red here. So I'm going to run it again. So what we do to do that is let's go to, and real fast before I do that, in production, it would never be set to just 120 seconds. This is set up just for demonstration purposes. We want to learn everything in just 2 minutes so that we can show anomalies. In production, you're going to have that set up to, a month or 6 months or, and this is dynamic learning too, which means it could take even longer than that. Dynamic learning is an automated learning process where the artificial intelligence is doing the learning for you. So that's 120 seconds without standard deviation. In most cases in production, we would want to go a couple of weeks without standard deviation, which could take a few months. You can also set to learn for a specific period of time. So I'm going to set it to keep it at the dynamic 2 minutes. If you want to follow along with me, how we're doing this is administration. You want to go to data, and we're going to reset the data. So then you plug back in your password, and when you do this, it's going to reset the learning as well. So this will restart that 2 minutes that we have to play the packet capture and see if we can get things baseline. So I'm going to reset the data. It's resetting. Wait for that reset to finish. There we go. And let's run the PCAP again. So I'm going to go to administration, upload PCAP, and let's play that base PCAP. So it should be building out again from scratch. I'll watch the learning this time. So if you change the perspective, so the perspective is how the links and the nodes are viewed on the network. I'm going to change this to not learned. You know what? I think I know what it is too. It's the PCAP timestamps because we're playing it in the graphical interface. So let me clear it one more time and then not use those PCAP timestamps. basically what we're doing in that case is playing the PCAPs in the past. So reset, upload PCAPs, uncheck the box that says use PCAP timestamps. So this will actually assign new timestamps for it, and this should work, I think. Let's play that. There we go. Found the broken part of that. So now everything here is gray, which means it's being learned. So we're able to successfully get the learning working. So this, if for those of you that are following along, if you want to have the learning working for anomaly detection mode, make sure when you replay the PCAPs, you uncheck the box that says use PCAP timestamps. It defaults to that, so you actually have to uncheck it and then play the base. So reset the data, play the base PCAP with that box unchecked. So if we go back to the graph, now we can see everything is being learned. So I have the perspective set to learning. I can set it back to roles. We'll show you the device types. Or if you set the perspective to, see what's in here, zones, not learned, transfer device, public. Public is a good one because this is showing you which devices are on the internet. So in this case, I can see that there's a connection from this iPad to this device that's connected to the internet. So if you think back to my presentation, that's one of the first things that we'll do in a proof of concept or in production is look for what's connected to the internet. You can do that quickly with this public nodes. But not learned is nice because what it's showing us is show me everything on the network that's not learned. And in this case, everything was picked up by the learning engine. So the learning process takes about 2 minutes. I want to give that a few more minutes. The alerts now are empty because the learning is working appropriately. So we have no alerts. Network is filling out appropriately. Let me just unset the filter on Windows so we can see everything. There's other tabs other than just the nodes. You can look at all of your links as well. You can sort this with your from and to zones, so you can know, you can identify where your intra-zone communications are. You can do this on the graph as well. I'll show it on the graph. I like to sometimes show this also with the retransmission percentage. You can sort by retransmission percentage to see what links might potentially be broken. So if I sort this by retransmission percentage, I can see I have a bunch of SMB links here with a 50% retransmission rate. So a lot of cool stuff you can do there. On the graph, I mentioned on the graph, we can do some stuff with the zone. So we do a layout. We can set it to a clustered mode. So this is, if you zoom out, this is meant for if you've got, so in this case, for the demonstration, we've got a few hundred nodes, but we're capable of monitoring tens of thousands or hundreds of thousands. And clustering allows you to zoom out very far when you've got hundreds of thousands or even millions of nodes, and kind of see it in with counts instead. And then when you zoom in on any of the clusters, then it'll kind of break out into those individual nodes. Still kind of in beta right now, but it's an interesting way to look at this. Let's look at groups. Do we have any groups? No, I don't think we have any. Oh, group by. There we go. Group by zone. There we go. So now we're grouping all of the assets based on which zone they're in. So we can see our CCTV network, building automation network, production net A, production net B, voice over IP. So the grouping allows you to kind of group the nodes in a number of different ways. We can also group by Purdue model level. So I can see all my zone 1 all the way up to 4.2, 0, 0.5 by role. So I can see all my producers, consumers, DNS servers, terminals. There's a lot of different cool ways to do that. You can also do a Purdue model graph this way as well. So if you want to break it down into kind of layers, this is a Purdue model layer. You can see the communication between the different levels of the Purdue model as well. So you can look for those links that maybe shouldn't be there between your zone 1, and actually there's some connection from your industrial devices all the way up to some SMB links there that definitely shouldn't be there. So there's a lot of cool ways to graph this out. But anyway, let's go back to our standard and look at what's learned. And all the learning should be done. So we're going to go back and play that other PCAP. Go to upload PCAPs again, unclick this timestamps box again, and let's run the attack again. I'm gonna go back to the graph. There we go. So this is getting more interesting. So now that the learning is complete and we're running this with the learning done, we start to see more interesting stuff. So everything in gray is what was learned. Everything in red is new. So we've got some new stuff going on in this network. So I've got a new connection to from a, this looks like a, here we go, a Hue bridge. So this is a lighting bridge connected to Google. That may or may not be malicious, but at least we can see that it's an anomalous. So it's not, it wasn't something that was learned. And here we have on the production network, we have a new host that showed up. Not that one, this one, there we go. So we have a new host that showed up and it communicated via SMB to our master station here, and everything in yellow is modified. So in this case, we can see that the master workstation is modified. This link was modified and something that this PLC was modified. If I click on that link and go to info, I can see what the changes are. So I can see that before we only had read registers and Modicon Unity, function code 90 and function code 3. Now we have function code 6 to write registers and function code 8 for diagnostics was kind of sent in. There was also an attempt at an SSH connection. Go to our alerts. Should be more interesting this time with the learning and the anomaly. So we had 0, now we have 24 alerts. I'm going to group it by incident to turn the correlation on. There's some interesting things. We see the new attempt to start public internet access. That was that light bridge. This time we see the SMB connection and the Dragonfly malware. Some more internet navigation stuff, some new nodes. Go back. Let me see what other. I'm going to go into the expert mode again. And see what else. New consumers, all good. So let me go back to, we'll go back to the threat alert here. I'm gonna open the details of that. So this is that Dragonfly attack, except this time because we have the learning, all the correlation could happen. So we see a new asset on the network, a suspicious packet sent via SMB. The SMB server is Microsoft Windows. And then we see a suspicious transfer of the malware. And there's that SMB link. And if we look at the related alerts, which you can see with this this button right here, you can kind of link together all of the different things that happen there. On page 2. All right. So you kind of work out the entire process from that node entering the network for the first time, connecting to the SMB share, sending the malware, and compromising that master device. It's a lot of kind of interesting activity there. Also see some network scans. We're part of that traffic that we dropped in. An IP address with a known generic or with an IP that's associated with malicious activity. So we know that this label is clients.google.com, but we're identifying that this IP address is known to have malicious activity that happens with it. That's what that light bridge connected to. So all in all, just some interesting things there to look at. So we're down to the last 15 or 20 minutes or so. So I want to make sure that we leave time for questions. So let me go back to GoToMeeting here and pause. Can everyone still hear me? I lost the GoToMeeting window.
Yeah, sure. We still hear you.
Okay, great. No, I found that sometimes when I'm playing things on the screen, I lose the GoToMeeting window stuff, but I think I found it again. So there is a bunch of questions. I want to make sure I get to those, but let me see, where's the rest of it? There it is. So let me pause that real fast. I'll pause it on the interface so you can look at that some more. Let me go to the questions. All right.
Yeah, so we got the first question from Ali Misbah. So the question was, would you elaborate about OT and IT and now are getting merged?
Yeah. So what we mean by the merging of IT and OT, or we'll call it the convergence is the word that we often use, is what we're seeing is in the past, the operators were often responsible for their own cybersecurity. Everything that happened at the plant was the responsibility of the operator, and that meant not just running the process and running production, but that meant, you know, getting the networking done and getting all the cybersecurity done all tended to fall on the plant operator. That's becoming less and less a burden on the OT side as time evolves. What we're starting to see is that the security teams for the organization, so if you think of your big oil companies or electric producers, the chief information security officer and the security teams for the overall organization are starting to take ownership of the cybersecurity for the operational side and not just the IT side as it had been in the past. So now, if there's a threat to the operational system, it doesn't just fall on the plant owner. It's more and more likely to fall on the CISO, and the CISO is being given the resources needed in some cases to start to take action to put defensive measures in place, put monitoring tools in place like Nozomi, versus relying on the operator or the vendor, so the ABB or Siemens or Schneider Electric in this case, to just take care of it. That's when we say with that convergence, we're saying that convergence in who's responsible for securing these systems has been underway for a long time, especially with some of the bigger attacks in the earlier part of the decade. And we're starting to finally see that the CTO and the CISO and the board of these organizations understand that cyber attacks on the industrial control systems are not only possible, but if they happen, they could cost an organization a lot of money, and they're taking real concrete action to put somebody in charge of making sure that those systems are secure. Does that make sense?
Yeah, absolutely. Well, I mean, hierarchy speaking, we still face diversity between the control systems and the IT. So I believe specifically in the government sector. So you still see the department, which is a completely different, run by, the control guys and control engineers and mechanical and electricians. And they are completely separated, and it's a war announced in case somebody from the IT want to get into them, or the vice versa. So this is, I believe, one of the very basic questions and very common ones in Iraq, because we still face diversity. And I think in some of the emerging projects, specifically by the ones that are executed by the global vendors like GE, Siemens, ABB, we start to notice they are emerging in the right way. But in the government sector, I don't think it will happen anytime soon.
Great. And I see that some of the questions have been answered too as we go along here. So I see Hensa, you were following along. You saw the read holding registers. Read holding registers, that's just a function code within Modbus to read the values that are coming in the process. So in that case, let's go back to saying that that's a turbine. What the read registers is doing is just reading the speed of the turbine, for example, but not actually writing anything, which is why it was so anomalous when we started to see the new function code for writing registers. There was another question there from Hensa about quarantining. How is it possible if we're a passive solution? This is important, is that what we're doing is we're in the mirrored traffic, we're just quarantining it within our box so that we can evaluate it. That does not mean it's being quarantined on the network. So on the network, because we're passive, we're just dealing with mirrored traffic, that file is still passing around. So we're not actually doing anything on the actual production network to quarantine it. When we say quarantine, we mean that we're quarantining that file in our sandbox for our analysis within the tool.
Perfect.
Great. So next question we're facing. So this is Dare. One of the problems we're facing is government employers in Iraq is not being willing to pay for these kind of solutions due to lack of awareness of information security and having the wrong people running IT departments. this is a challenge. It's not just an Iraqi challenge, right? This is a challenge in a number of places, and even in some organizations in the societies that want to think that they're further along, like America and Western Europe. That there are certain organizations that still run their departments this way, or even just departments within those organizations that run their processes this way. So that all we can do in those scenarios is work to bring that awareness and bring that threat. The details of those threats. Who's going to be responsible? Who's going to be losing their jobs, or seeing their credibility suffer if an attack happens and is successful. So webinars like this and getting those visible to the right people. That's an important step in making sure that people start to become aware of the threats and what that might happen. What someone acting on those threats could potentially mean to the organization. And until then, sometimes you just have to take measures. If you're not getting budget, there's steps that you can take to kind of do things without cost to at least start looking. Right? There's open source threat hunting tools and monitoring tools. As a matter of fact, Nozomi Networks, we offer a free version of this solution. It doesn't have everything that you saw today, but it's a nice starting point if you can't get a budget to show the power of a tool like this and maybe start working on getting that budget. It still does the visualization and shows you the protocols for some of the most common protocols. That's the Guardian Community Edition. So you can look at the Community Edition, but there's other open source tools out there that you can use to start to to get some visibility into the network and start uncovering threats. And if you find something, that could be the tool that you need, the ammunition that you need to go and say, hey, we really need to be looking at this. And if we don't, something bad is going to happen, and all of you that aren't doing anything are going to be held responsible. We've seen in the last 10 years plenty of examples of very dangerous attacks on industrial control networks. There was starting from the Stuxnet example in Iran was an obvious one, probably over marketed at this point, but that was serious. That was an air gap network. That was a threat that came in via USB stick, and that actually changed the speed of the centrifuges and destroyed the process for many years. We saw the Ukrainian power outages during the conflict between Russia and Ukraine, where the power in Ukraine went out due to cyber attack for several hours, and it was only brought back up because they were able to move to manual control of the power generation and distribution process versus using the automated control system. We saw the Triconics, the Triton attack in Saudi Arabia, where there was an actual attack on the safety instrumentation system. A few steps away from potentially causing that facility to have an actual explosion for people to actually die. Thankfully, the payload did not include the instructions to do that. I don't know if it was because it was just a test or they weren't ready to go that far, but for whatever reason, you can almost say that they got lucky, that everything was in place for there to be an override of that safety instrumentation system and for people to get hurt or die in that attack. And the payload didn't include enough information for that to happen, but it was almost there. So there's enough examples of really serious attacks on critical infrastructure, attacks that could cost lives, and it may not be in the attack itself. So like the Triton attack, if something exploded, someone at the plant may have died. But think of a power outage. A power outage may not mean someone at the electric generation facility is going to be hurt or die, but if that power is something that's being relied on for a hospital or the oxygen tank in someone's home, people can die because of the power outage caused by that cyber attack. This isn't a cyber related incident, but in the major power outage in the northeastern United States in 2003 or 2005, that was caused by a squirrel, believe it or not. Maybe it was ice in the line. For whatever reason, the transmission line hovered too low. It started to dip too low, and it got caught in a tree, and the transmission line went down, and there was a cascade effect that actually ended up bringing down the substations across the Chicago metropolitan area, and that cascaded to the entire Northeast. It was just a power outage, and it was just 18 hours or so, but they directly attribute almost 50 deaths to that power outage due to people not having heat or not having their oxygen turned on, or other life-saving tools that they were using to keep themselves going due to that power outage. So the potential impact of a cyber attack infrastructure is not just someone losing money or reputation. It's it's death and destruction in some cases, and you don't want to sell a program by fear. You want to point out the value, but at the same time, there's serious consequences for the people responsible for that if they're not acting on it.
So the good thing, Mike, is that we don't have squirrels in the region. So
Yeah, I didn't think of that till after I said it.
and I doubt that we'd have camels or getting in the power lines.
Driving the power lines, but it could be anything, right? It could just be somebody wanting to cause mayhem. There's plenty of mayhem, so you never know. We have a comment here from Mohammed Aboud, which is really okay. This isn't really a question, just a thank you to the presenter. So thank you, Mohammed, for joining and paying attention and participating today. We appreciate it. Does the free version of the Nozomi software come with any training course on how to use it? And can we have a link? So yeah, give me just a minute and I'm going to provide a link in the chat. And there are instructions that come with it on how to use it. And you can also reach out to our Guardian Community Edition support team that can provide additional instructions. So give me just a minute. And I will post that link in the chat. So same chat window that I put the IP addresses for today's trial. There's a link in there now for our community edition. So I think you just need to provide an email address maybe, but you can download the free version with that link.
So there's a question about IoT in banking sector, and the answer is yes. It's not just banking; it's about the technology itself. So any sector where you have HVAC as a critical system, CCTV as a critical system, any IoT as part of a critical system for the operation and process of the industry, security becomes a pressing issue. So in the region, we're talking currently with a number of financial institutions because they're trying to secure their smart buildings, they're trying to secure their HVAC systems. Because think of a data center, right? You're investing a lot in IT, in your firewalls and your security solutions. But the easiest way to take down a data center or a stock market is to take down the HVAC system, because basically, same thing with healthcare. So with healthcare now becoming something prominent during these during the pandemic, there's a lot of focus on securing the medical IoT and IoT devices because the medical sector is being targeted, and they share a lot of systems, believe it or not, with the banking sector. I don't know if Mike, if you want to add anything to that.
No, yeah, that was a good answer. I think IoT, we kind of see it just about everywhere, right? And that it could be as simple as the camera systems, the physical access systems, how you badge in and out of the facility. In many cases, the locking mechanisms for storage within the banking sector is an IoT system as well. Not everywhere. That's kind of a new thing, but that whole badge access or code access system that's considered IoT, and there's a lot of things there that you may need to have monitored for sure. I think we're down to the last few minutes, so I think we ran out of questions. If nobody has any additional questions, I did try to. I went while Farouk and Bashir were speaking earlier. I did try to go through the list of attendees and connect everybody on LinkedIn. You're welcome to find me and connect to me if I missed you. But happy to answer questions after the fact. You can also, of course, reach out to Khalid or Bashir. But really appreciate everybody participating, and look forward to potentially hearing from you all in the future as you start to get your systems monitored.
Thank you very much,
Khalid, anything to add?
Khalid, maybe you also missed the opportunity to join us in the beginning. You were protecting another customer, so you can close it. Actually, I will leave it for you to close it.
يعطيك العافية شكرا. السلام عليكم جميعا. Hello everyone. I do apologize I joined a little bit late. My name is Khalid Al-Jamid, so I look after the Nozomi business for part of the region, including Iraq. So I would like to thank all of you for the session, for attending the session, for your interaction. I would like to specifically thank Mr. Farouk for arranging this, for his partnership. I think we will do a lot of great things that we have in plan with cybercode for the region, for Iraq specifically, the Iraqi market, whether it's in oil and gas, whether it's in the utility sector, whether it's in the IoT for government and non-government sector. It's a huge market. The geopolitical situation in this region, the growth that we are seeing, the opportunity is huge. It's not just about security. It's about process. It's about optimization. It's about taking advantage now of the new wave within technology for both IT and IoT and OT. This is a great opportunity that I see in front of us that we can work together. It's a niche technology. I know that there are a lot of questions. We are more than happy to address them in further sessions and more deep dive sessions and one-on-one sessions if you are willing to. So please reach out to Mr. Farouk, to me, the rest of the team. We are here to support you. فرصة سعيدة وإن شاء الله we will continue having more and more sessions like these.
Thank you very much, Khalid and Michael. Appreciate it, and definitely we don't forget Nadine and the exclusive network team also for hosting you today. And thank you for everybody for hanging out with us for a nice 2 hours. And it's an official end of the work week, so you can enjoy the weekend. يعطيكم العافية. Thank you very much. السلام عليكم ورحمة الله.
Thank you.